The final step of the process is to apply the proper amount of torque to each fastener in a star pattern. This will help ensure that the clamping force is sufficient and evenly distributed around the hub.
While there are many different methods for tightening wheel fasteners, the most accurate approach has traditionally been the manual torque wrench. Torque wrenches are often considered labor-intensive, but they are very reliable and accurate tools that ensure the proper torque is applied to all wheel fasteners. However, there is a new breed of pneumatic nut runners that combines some of the speed associated with the impact wrench with the precision and accuracy of the standard torque wrench. In some instances, these gear-driven tools require a special air regulator or a minimum air pressure in order to operate correctly. These tools shouldn't be confused with standard air-powered impact wrenches. Impact wrenches utilize a hammer mechanism that are not considered torque control devices, so they should not be used to set the final torque. However, impact wrenches can be used to snug the nuts in a star pattern to ensure the wheels are properly seated. Whatever method is selected, the end result on disc wheels must be 450 to 500 foot-pounds of torque on each fastener. While the effects of under-torque are obvious, over-torquing the fasteners can be just as dangerous. When torque is applied to a fastener, the stud is stretched slightly under tension, but returns to its original dimensions when the fastener is removed. When excessive torque is applied, the stud is stretched too far, which results in a weakened stud that can fail during service. On a hub-piloted flange nut, just 2 seconds of impact time with a 1-inch impact wrench can result in almost 700 foot-pounds of torque, almost a 50% increase over the recommended torque of 475 foot-pounds. But technicians must still remember that the correct torque does not guarantee the correct clamping force if the components are in poor condition or improperly installed. That's why it's important to always check fastener torque after the first 50 to 100 miles of service. On disc wheels, the best practice is to set the torque wrench at 475 foot-pounds and then attempt to tighten each of the fasteners. If none of the fasteners move in a tightening direction before the wrench clicks or the handle breaks, then the torque is at least 475 foot-pounds. If the fastener shows slight movement in a tightening direction before the wrench indicates 475 foot-pounds during the torque check, then the assembly should be inspected for any other signs of loose or damaged components. If the fasteners experience significant movement before the wrench clicks or the handle breaks, then the wheel should be completely removed from the axle so all of the components and mounting surfaces can be carefully inspected. When a wheel-off occurs and the assembly strikes another vehicle, the resulting impact can be devastating to the driver and any passengers. In this controlled test, a standard low-profile truck tire strikes a stationary vehicle at approximately 55 miles per hour. The vehicle is moved almost 4 inches, and the damage to the driver's door and door jamb is significant. After colliding with the vehicle, the inflated tire was launched over 20 feet in the air and finally came to rest 100 feet in the opposite direction.
As you can see, the risk associated with wheel-offs and wheel-end fires are very real. By following the recommendations in this video and implementing a wheel-end maintenance and safety program, we're confident that fleets can reduce the chances of an accident and improve wheel-end performance. On behalf of Michelin North America and the Tire Industry Association, I'm Doug Jones. Thanks for watching.